Welcome to The Explainer. Today, we are pulling back the curtain on the hidden foundation that makes or breaks, well, pretty much every piece of tech you use. From the apps on your phone to these massive systems that run global companies, it all starts with a blueprint. But first, let's start with a story you've probably heard before. It's a tale that happens way too often in the tech world, and believe me, it costs companies millions, sometimes billions of dollars. You've felt this, right? A brand new app finally launches, and it's just slow. It's buggy, it crashes. Or maybe you hear about some huge corporate IT project that's gone wildly over budget, and in the end, just doesn't deliver. This isn't just a string of bad luck. So what's really going on here? Well, all those things, the crashes, the budget overruns, the security holes, they're not the disease. They're just the symptoms. They're symptoms of a much, much deeper problem that started long before anyone wrote a single line of code. They are symptoms of a failed blueprint. Okay, so the answer to stopping all this chaos is actually a really disciplined, upfront process. It's all about defining the project's essential blueprint. This is where you lay the groundwork for success. Now, the official name for this is requirement specification. But think of it like this. This is the phase where the architects and engineers get together and draw up that incredibly detailed plan, defining every little thing the system needs to do before a single brick or, a line of code is ever laid. And honestly, this analogy just nails it. You wouldn't hire a construction crew, have them show up to an empty lot, and just say, go for it, start building, right? You'd be insane. The exact same discipline has to apply when we're building technology. And creating this blueprint isn't just some one-and-done task you check off a list. No, it's a critical thread that's woven through the entire building process, what's known as the Software Development Lifecycle, or SDLC. You can see it here. It starts as just a rough sketch in the planning phase, gets more and more detailed during analysis, and then becomes this rock-solid, finalized blueprint right before the actual building begins. Okay, let's really dive into the two halves of this blueprint. We're going to start with the software, which you can think of as the digital engine of the whole system. So, to put it as simply as possible, the software is the brain. It's the set of instructions and the logic that tells the system what to do. And the hardware? That's the body. It's the physical machine that actually carries out those instructions. You absolutely have to have both, and they need to be working in perfect harmony. Now, software really comes in two main flavors. First, you've got the foundation, the system software. Sticking with our house analogy, this is like the concrete foundation and all the electrical wiring. It's the operating system that makes everything else even possible. Then, sitting on top of that, you have the application software. These are the things you actually use, like the appliances and furniture, say a custom payroll app or Microsoft Office, that do a specific job. And of course, to build all this stuff, developers have their own toolbox, programming languages, databases, you name it. But here's what's really cool. There's this stuff called middleware that acts like the glue holding different programs together. A great example is an API. You can think of an API as a kind of universal translator that lets two totally different apps talk to each other and work together like they were made for it. All right, so we've covered the brains of the operation. Now let's talk about the brawn, the hardware. This is the physical machine that provides all the raw power to make the magic happen. So hardware requirements cover everything you can actually touch. We're talking about the keyboards and monitors that people use to interact with the system, the powerful servers and CPUs that are doing all the heavy lifting, and of course the storage drives where all that precious data lives. And this is so important. The blueprint also has to include the networking gear, the routers and firewalls that connect everything together, and the backup systems, the power supplies. This is your safety net. This is what keeps a small problem from turning into a total disaster. So, the whole point of defining all these hardware needs is to create an incredibly precise shopping list. It doesn't just say, hey, go buy a server. No way. It says, buy this many servers with this specific processing power, this much memory, and this type of storage. It completely removes the guesswork for the people who have to go out and buy all the equipment. And look at this. This slide right here, this is where it all comes together. This is the blueprint in action. You see how it's not vague at all? For software, it doesn't just say, we need a database. It specifies MySQL and makes a note about versions and licenses. For hardware, it calls for 2 quad-core servers with the exact RAM and storage specs. Every single item is detailed and totally unambiguous. This is the level of detail that prevents failure.
So, how do you actually create one of these detailed blueprints? Well, it's not random, and it's not guesswork. It's a structured process with very, very clear stages. You start by reviewing the initial designs to really get what the goals are. From there, you logically figure out all the software you're going to need. Then, you identify the hardware you'll need to run that software. After that, you check for compatibility, you look at the cost, and finally, you document everything to get the official sign-off. You see, each step just builds logically on the one before it.
So why go through all this trouble? Why all the detail? It's all about finding that perfect sweet spot. The whole point is to avoid the two silent project killers. On one side, you have underspecification. That's where you get cheap, you don't buy enough power, and the whole system just collapses under the load. And on the other side, you have overspecification. That's like buying a Ferrari engine for a go-kart. I mean, it's cool, but you just wasted a ton of money. So what's the big takeaway here? Getting this blueprint right is absolutely, fundamentally crucial for success. It's what makes sure the system actually runs smoothly, it keeps the budget from spiraling out of control, it prevents those nightmare launch day failures, and it makes the entire project, from buying the gear to planning future upgrades, so much easier.
So I'll leave you with this thought. The next time an app on your phone is slow or a website you're using crashes, just ask yourself, is that really the coder's fault, or was the blueprint flawed from the very beginning? It's a powerful shift in how you look at things, and it's a reminder that true digital success is almost always built on a solid and visible foundation, planned long before a single line of code is ever written.